This looks like a rule you have to memorize. 2 to the third times 2 to the fifth. But nothing here is arbitrary. This follows directly from what a power means. Now let's rewind. In the last video, we defined what a power means. A power tells you how many times a factor is repeated. In this episode, we use that definition to explain why the exponent rules work. We will look at 4 quick examples. Each one shows where a rule comes from. No shortcuts. Example 1. We're multiplying powers with the same base. The key idea is simple. We're putting repeated factors together. Once everything is written as a single product, the exponent simply counts how many copies remain. That is why the exponents combine. Example 2. Now we divide powers with the same base. Division removes matching factors. What disappears does not get counted. So the exponent tells us how many copies remain after cancellation. This is the same idea as before, just applied through division. Example 3. Here we raise a power to another power. The inner exponent already represents a multiplication. Raising it again means repeating that entire block. So we are not adding anything, we are repeating a repetition. That is why the counts multiply. Example 4. This one combines multiple methods that you have just seen. We simplify step by step using the same base throughout. First, we combine factors. Then, we remove factors. We are only keeping track of how many copies remain. Every rule you just used comes from the same definition. Exponents are counts. Multiplying combines counts, dividing removes counts, powers of powers repeat counts. That is all that's happening. 3 things to remember. When you multiply powers with the same base, you add the exponents. When you divide powers with the same base, you subtract the exponents. When you raise a power to a power, you multiply the exponents. These are not separate ideas. They are all consequences of the definition. Now try this one. Combine the powers first, then subtract. Take your time and check each step. You now know why the exponent rules work. The next question is, what happens when the exponent is 0 or negative? That video is on screen right now.